Okay, we have now covered our first two learning outcome, which is understand database management, where we've defined what is data and what is a database. And we've looked into the type of database. And after that, we've looked into, we were able to define ERD, database management system, with entity relationship diagrams. And then we looked into designing this type of databases and what are the software required, such as Oracle databases, MySQL, and PostgreSQL. And in today's session, we will focus more into the implementation of a database. And we will now look into SQL and how the functionality of SQL are used to store information into databases. So before we dive into this session, I would like to watch a quick video which will explain some concepts of database of ERD. So as you can see from our indicative content of today, we're going to look into data construction, look into advanced SQL queries, user action, then we'll look into implementing database features, such as database security features and database links, and also graphic user interface. And conclusively, we're going to have a database testing, where we'll have a testing plan, a database components, and we'll have extreme data and error handling. So let's just watch a video, experience in detail ERD. And ERD.
Hi, my name's Taylor and I'm from Lucidchart. Today you'll be learning all about entity relationship diagrams, or ERDs. We're going to start off by discussing a high-level overview, and then together we'll dive in and build an example together, complete with entities, attributes, relationships, and cardinality. By the end of this video, you'll be able to build an entire entity relationship diagram from scratch. Have you ever wondered why you get an error message telling you that your ideal Twitter handle is already taken? Or how Amazon can keep track of so many different orders and customers and products? The answers to these questions lies within the creation of a database, which, in other words, is a collection of information that is organized so data can be easily stored, managed, updated, and retrieved. Now, there's a lot of moving information in a database, and understanding how the many elements of a database interact with each other can be difficult to grasp. Engineers need a visual way to understand how all these separate elements are related to each other and how they're working together. To show this, they build entity relationship diagrams. So let's talk about how you're going to make these ER diagrams. You can draw them out with pen and paper, but it's going to be way easier for you to use a diagramming tool. Today, I'm going to use an easy-to-use tool called Lucidchart, and you can too, for free actually. By clicking on the top right corner here, you can access Lucidchart's website, enter your email address, and have a free account in just a few seconds. That way, you can follow along with me and continue building your own ER diagrams as well. Before we can create an actual ERD, we need to better understand the individual components of the entity relationship diagram. And this is going to start with entities, which are an object, such as a person, place, or thing, to be tracked in the database. For example, in the case of buying something on Amazon, let's say a Snuggie, an entity could be a customer, an order, and lastly, we can't forget our Snuggies, the product. Now, each one of these entities is going to have what we call attributes, which are various properties or traits. In this case, under the customer entity, we have a customer ID, first name, last name, street, city, zip, and phone. It's important to remember that the entities in your database will be the rows, and that the attributes in your database will be depicted as the columns. Now we have the different entities and the different attributes on the screen here, but now let's talk about the relationships that exist between these different entities. The relationships describe how these entities will interact with each other, if at all, and you do that by drawing a line in between them. So when I draw a line in between these particular elements, I'm showing that there is some sort of interaction or connection in some way. Now that we have our relationships in place, you'll see some funky notation attached to these lines. This, in fact, is called the cardinality, which further defines the relationship in a numerical context, particularly within minimums and maximums. So for example, here on this right side, you can see some different types of cardinality we have in ER diagrams. We have one, many, one and only one, zero or one or many, zero or many. Now don't be afraid if this isn't making sense quite yet. We're going to walk through some examples that'll help you understand this perfectly. So let's talk about the relationship and the cardinality that exists between a customer and the order. Now the best way to do this is to think about it logically. We have to think about what is the minimum number of orders that a customer could have, and what's the maximum number of orders that a customer could have. So let's start with minimums. What is the minimum number of orders that a customer could have? Well, a customer could exist, but he or she could have 0 orders. So to show that over here, we'll have that 0 sign. Now we have to think about the maximum. What are the maximum number of orders that a customer could have? Well, as you probably already know, a customer can have infinite orders. In the case of Snuggies, you can never just have one Snuggie. So to show that, we'll use this 0 or many crow's foot notation. Now let's talk about the minimum and maximum relationship between orders and customers. So we ask ourselves the same questions. What is the minimum amount of customers that an order may have? And what's the maximum number of customers that an order may have? Now, a specific order can only have one and only one customer. Well, you can imagine the confusion that could come if the same specific order had lots of customers. So in this case, there can be only one and only one number of customers to an order. And we can show that using this sign here. So now let's talk about the relationship or cardinality between orders and products. So we'll ask ourselves the same question. A certain order can have how many products? Well, for an order to exist, it has to have one product. But a lot of different products can be comprised of that order. So to show that on our diagram, we'll change this notation. Now we ask ourselves that question in reverse. A product can be a part of how many orders? Well, a product could be a part of no orders, but it also could be a product of many orders. So we're going to use this 0 or many notation on our diagram. So now you've built your entire ER diagram, and we've built something small here, but now you have the foundation and framework that you need to build complex, complete entity relationship diagrams. Although this can seem a little bit overwhelming at first, just be sure to walk yourself through that logic, and you'll be able to build entire complex ERDs. You'll also see on this diagram that there are some unfamiliar objects such as PK and FK, which refer to primary keys and foreign keys, something that we're going to be covering in a video coming soon, so stay tuned. Additionally, if you need to actually have this diagram to be database ready, you can use the import and export features of Lucidchart to have all of that done automatically for you. Using the export feature, you'll have that code automatically generated for you and exported to the database management system you're using. Thanks for watching this tutorial on ER diagrams. Subscribe to our channel below to get access to more helpful videos and tutorials. Leave a comment as well if you have any thoughts or questions on ERD. And don't forget, sign up for a free Lucidchart account by clicking on the link in the top right corner. Thanks.
So this video was really insightful, and they gave us basically an overview of how this software entity relationship diagram help us building codes, and with software like Lucy Chart, you create the query for us. So as we saw at the end, there was a query, and that query can be imported directly into our Oracle database or our MySQL database application. So when it comes to working with queries, there are two main characteristics that we need to look into. So the first two categories of query are data definition language, where we're simply going to define our tables. So we're going to define our schema. And then we have data manipulation, whereby manipulation is simply going to delete, update, retrieve, and create our queries. Also, we have SQL persistent storage model, which will now add procedural programming capacities, such as working with variable or control flow statement, such as if, else, and other control flow statement. So so what is Cape Cod retail sales structure? So this is an example of a retail company where they have customers, which could have now where they have different type of stores. They have online customers, and what happens is that these people will now try to purchase product, any type of retail product, and there will be type of user interface that allows us to that are connected to our database. And by having this database, we have to be able to do data. We have to be able to do data definition and manipulation. So when it comes to extracted retail sales data format, this is how our table look like. Well, we now have entities, and at the top, we now have our attributes, and we have data types. So this is an example of how this will be done. So when it comes to our data manipulation, there are a couple of functions that are important to know. So such as them is select, which allows us to select attributes from our table. Then we have from, which will allow us to retrieve from a specific table, and there and where we now give us some sort of conditions. As you can see, we can now select from our table. We can select a specific attributes from a table, and we now use from to select from which field this has to be done. Then we have distinction keywords. So this, for example, are keywords that cannot be replaced, and they are private keys, so they have one meaning. So what you have to do, you need to note that SQL wants a plain ASCII single quote, and what happens is that a value that is a unique value and cannot be repeated. Also, we have where, which will now tell us for instance, from which department this data has to be collected. So this could come from any type of field, such as our attributes. So we now have where option, which we can now use conditional statement, operators, such as and then or, which allows us to select multiple, with the and, we can now select multiple attributes. So we could now select water sports and another field, another attribute such as a name of the buyer. So this is how we are able now to manipulate our data, where we are able to select a product from a specific table and where we can get this from a specific department. So these are simple manipulation that we can do for us to extract data from our table. So SQL keywords like can be combined with wildcard symbol. So here we have an example of this keyword that can now be combined. This is an example of the type of wildcard that can be now combined. So there is also built-in functions for SQL, which are 5 of them, which are count, sum, average, mean, and max. So this built-in do not require us to retrieve them or make some query. These are coming as default. You just need to enter, you just need to select, add, for instance, sum or average or any type of function that we want to retrieve, and SQL will now automatically do the calculation. So we have sum, average, minimum, maximum. Count. So here's what we can do. So we can also query multiple tables at the same time. So it is possible for us to do a sum where we're extracting from our order item table, and we can now extract from our department. There are different type of queries that can be done. Also now, let's look into W3 school, where we can now understand what a joint is. So as we know, joint it is basically what the name says. So you now allow us to join two tables at the same time and manipulate them. Joins. So a join clause is used to combine rows from two or more tables based on related column between them. So as we can see, it simply allows us to join and to combine multiple rows with this type of tables. So this is a simple command where we'll have select. We're now going to select our table from, which is going to be the department. Then we have select or done. So we have we're selecting from a specific schema. From will now be the table. In a joint customer, then we'll now have order. So let's run this SQL. And this will be the output. Yeah. So that's the main purpose of a join. Okay, so coming back. So define join. Okay, there are different type of join where these can now be extracted. Okay, we have some simple command which allows us to create a database. So SQL keywords, for example. Here are the keywords that we now use when it comes to creating our tables. So this was everything for today. Is there any question?
No.
Thank you very much for joining, Shalom, and have a good day.